So let's see. Today I'm feeling much better, and you know, with a better understanding of this particular question. And so I'm going to cover this. And there was this question that I forgot to add in the description that I'm going to add as well, because this question is actually very interesting. So let's see. I'll take these two questions. Yeah. Okay, so reverse linked list 2. So let's quickly look at reverse linked list, the normal reversal, quickly before we continue reverse linked list 2. Uh, you know what? I did reverse linked list this particular question. I've had like two videos on it already, so um I'm not going to go over it again. But the point is, this question is a prerequisite for this question here. Even though there are some things that are not included or similar, it is still good to know this reverse linked list before you start this, or at least solve this question before you go into this one. This is a much the concepts behind this. I mean, it's easy to understand this question, but it's just the implementation that is hard, and which is what I'm going to cover today. So let's get started. Here is a solution that I will provide. But before I provide a solution, I would like to read the question again one more time for us to. Uh, so basic. Okay, this is what I've started yesterday. So let me read the question again. So, given the head of a singly linked list. Now, a singly linked list is just a linked list that has, you know, a single pointer, which means a next property on each of the nodes. So, um, given the head of that singly linked list and two integers left and right, where left is less or equal to right, reverse the node from the list from position left to position right and return the reverse linked list. Now, the question is simple to understand. It simply means we are reversing the nodes from this position here up to this part, which is what we can see in this picture here. Um, it is fairly straightforward, but it's just like I said, the implementation is quite not so straightforward as the understanding of the question. So let's see. So here's what I started explaining yesterday. Unfortunately, I could not finish this, but today I'll try to go over everything and finish it on time. So let's see. Let me remove everything here. Comment. So I want to remove all of these nodes like this and take out this node 2, this thing. So here's our linked list, right? So I'll just keep this image here for the sake of reference, and you know try to explain this question. So basically what's going to happen is we want to reverse a linked list from a certain position to another, right? So I'll the best way for me to do this and have more space is to just write it out. So I'll write the nodes. This is going to be 1, 2, 3, 4, and then 5, like this. So I'll remove this image from here, or at least I'll just, yeah, let me remove the image for now. I don't need it anymore. So here's our nodes, and we want to reverse this linked list from a certain position. Now, the normal reversal of linked list that we are used to is reversing the linked list from the head of the list to the tail of the list, right? And that is quite straightforward, given that we know our starting point at hand, right? And then we know where, we know we are going to end up at the tail of the list, which means the tail of the linked list will later become the head of the list, and the head of the list will become the tail of the list. But in this case, we are given two positions, right? Left and right. So our left position is at this point, and our right position is here, right? So what we need to do is to swap every node in between, right? And end up with something like this. 1, 2, 2 goes to this side, right? So 2 will be here, 2 will be at the end, 4 will come to 2's position, so 2 is here, 4 is here like this. Then we have 3 will remain at the middle because it will not move, and then 2 will come here, and 2 will point to 5, so which is what is in our result here. So how do we really reverse this linked list to become something like this? Well, for us to do that, we need to really go back on the position of every pointer in the linked list. So this is going to be left, and that is going to be right. Right is equal to 4 and left is equal to 2. So for us to do this, first of all, we need to know how much we would iterate through the linked list for us to move each node at each point. Because at the end of the day, what we will do is to simply change the pointer of every node in the linked list, right? And by pointer, I mean the next node for every node, starting from the left position to the right position. So here is what I mean. So let's say, for example, the next node of this 2 here will no longer be 3. Instead, it will point, at the end of the day, it will point to 5, right? And the next node of this 4 will now become 3 here, and then 3 will point to 2, right? And then 1 will point back to 4, right? So which is what we'll have at the end of the day. And for us to achieve that, right, we'll simply do it this way. So let's say in our iteration, right, for us to change the position of this next node, we'll first of all need to keep a copy of every node after this node, because at the end of the day, this node will no longer point to the node where 3 is. It will point to the node where 5 is, right? So for us to do that, we'll first of all set the current node, right? I'll call this a current node here, right? And then we'll keep a copy of this current node. Let's say the current node, a copy of the next value of the next pointer of this node, right? So I'll call that a temporary node, right? Or I'll call it so a better name is just temporary node. So I'll call this temp node, or let's just call this TN, right? TN is at this position, right? And current node is here. So we'll then change the next value of this current node to this node here, to the next the node after the temporary node, right? So we'll move this node from here to this point, right? So the next node after this current node will be 4 towards 5. So here's what our first iteration will look like. So we'll have current node, right? Current node will look something like this. We'll now point to 4, 4, and then 5, right? So meaning the link between current node and the temporary node is broken. Now the temporary node's next value, right, would then become the current node. So we can just say temporary node dot next. So tn dot next. All of this will happen in the first iteration. So tn temporary node dot next, right? Temporary node dot next should become what this is, right? This current node's next value. So it will become this current node. So 3, we'll have 3, 2, 4, 5, right? And then we'll update the node after this. I mean the node after where 1 points, right, to the current this node that we have here. So we'll say at the end of the day the linked list will look something like this. This is still the first iteration. So what just happened to my I don't know, the color just got dimmed. What's this? Oh, opacity. Okay, so at the end of the day our linked list will look something like this: 3, 2, 4, 5, right? 5, like this. So this is what we'll get at the end of the first iteration. Now you can see we simply switch the nodes, right? At least we move the left the node at the very left towards where towards the right, right? So we move at least we switch the position of 2 nodes so far. So now we'll do the same thing again in the second iteration. Right? I'll use a different color. In the second iteration, we know our linked list looks like this already. So we'll say this should be our current node did not change, right? Our current node did not change. Our current node will still be at this position, but then our temporary node will now become this, right? Will become 4, right? Where 4 is. So we'll say we'll then do the same thing. We'll change the current node dot next to this node here. So our current node will now look like this: 2 to 5, right? So again, the chain between this, the connection between this and that has been broken, and now this is connected to 5 here. So that's the same thing we'll do here. And then we'll take the temporary node again. The temporary node next value will be changed just the way we changed it here, right? The temporary node's next value will become the node here, right? So like I said, temporary dot next is simply every node after it, right? So the node after the first, where the left pointer is, so the temporary node will be this node here. Sorry, must have skipped a step. So the temporary node's next value will be the node where the left pointer is, right? Or where the left position is, which is this 3 here. So our temporary node is 4, right? So 4 dot next. So the next value after 4, right? So temporary node dot next. So our temporary node will be looking like this at the end of the day. So 4 will point to 3, 3, and then 2, and then 5, like this, right? And then we'll simply update our our the head of our linked list, the node after the head of our linked list, or where our head node points to, right? It will currently point to this node here. So we'll say at the end of the day, our linked list will be looking like this. So we'll have 1, and then 1 will point to t dot next, like this. And at the end of the day, we'll have our linked list looking like this. So 1 will point to t dot next is everything here, right? So 4, 3, 2, and 5, right? So now you can see the linked list has been reversed between left and right. Now the next thing to note about this is that there are some edge cases that I didn't put into account while solving this, but we'll look at those edge cases when I'm writing out the code. Because what if our left node, right, is at the very start of the linked list, right? Which means the head is where the left pointer is. So how do we account for that, or how do we write an algorithm that looks into cases like that, right? So we'll need to also look out for those situations. So I'm going to open my code editor now and try to write out some code for this problem. So I'm just going to copy everything here as usual. This will just be some edge case boilerplates. Okay, so that's all. This is a linked list question, so I'll create a new file. What's the name of this question? Reverse linked list 2 question 92. So new file, come on, reverse linked list 2. So lit 92 reverse linked list 2, right? So I'm going to remove all these optional parts here. I'll comment this so that this stays within okay. So left and right. So here's something I did yesterday. So if left is equal to right, so if the left and right position are the same, we can simply return the head, right? So there's no point doing any reversal at that point. So let's see what we can do here. So first of all, we'll need to know, for now, we according to this example, right? According to this example, the left here is 2 and the right here is 4. But what if the left is actually 1, which means it's at this position here, is the first node or the head of our linked list, right? Then in that case, we will want to keep a copy of we want to change our linked list, right? And so we'll create a new node, and then set the next value of that node to our current head, and then use that node, that copied node we just created, for the reversal of the nodes between left and right pointer. So let me show you what I mean by that. If we had a linked list like this, 1, 2, 3, 4, and then 5, right? If we had a linked list like this, and we're supposed to reverse this and that, right? So left will be here and right will be here. This can be done because, I mean, we know exactly where our left pointer is, right? But what if the left pointer is at this position here? Sorry. What if the left pointer is here? Was here, sorry. God, I'll just keep erasing this thing. What if the left pointer was at this position here, right? Was at the head or the very start of our linked list, which means the reversal has to be done from this point up to wherever the right pointer appears here, right? So for us to be able to do this efficiently, we need to keep a separate node. I mean, we can set the node value to 0, right, and connect that node to our original linked list. So at the end of the day, our reverse linked list will simply be returned by, we can just return the our fake node, right? Our fake node, fake dot next, because the next value in this linked list will simply still be the head of our original linked list, right? So to get the head of our original linked list, we'll just return the fake node's next value, right? So let's create a fake node and then do that. So I'll say our fake node, right? So I'll say fake node. I'll call this fake node, and then I'll set this fake node. I'll set this fake node to be an instance of the list node, right? Now, the good thing about this is this list node takes 2 arguments, right? You can see there's a val equal to 0. They are just default values. You can instantiate it like this without passing anything. It will set this by default, but we can also do this like this by just simply saying, okay, so our value will be 0, and then the next will simply be the head of our linked list, right? So this is okay like this. Now after getting our fake node, right, we need to know at which point our left pointer or the reversal of our nodes will begin, right? And for us to access that point, we need to get the node right before the left pointer, right? So if our left pointer was supposed to be let me erase this. If our left pointer was here, right, and our right pointer was here, then we'll need to get the node right before the left pointer, right? So for us to get that, we'll simply iterate 1 less than the amount of the left, right? So left could be 2, left to be 2. So for us to get to this point, we'll iterate 1 less than 2, right? So which means our iteration has to run only 1 times. So let's do that here. So I'll say so for we don't need any for in range, we don't need any I or iterator variables here. In range left -1, right? We'll simply say so we'll create a new tracker. I'll call that the previous, right? it should be the node where the node previous, I mean the node before the left, right? So I'll call this node before left. Before, should I call this node before left? Yeah, node before left, like this. Node before left will be, oh, somebody, oh, the question is in the description. You can have access to it in the description. Yes, I have it in the description below. So kindly check in the description. Yes, Sanjay. Yeah. So I mean, we can say node before. Uh, so node before left will simply be equal to the fake node again. I can just set this to the fake node, and then say, okay, node before left again. Node before left um will be equal to fake node dot next, right? So this would have moved our node to a node before the left, right? The left that we have here. Now after getting that node, right, we want to get a current node for our iteration, our proper iteration, which is going to be the right minus the left time, right? So we'll set, I'll say current node, right? Current node will simply be equal to node, or I'll call this node at left, right? Let's call this node at left. To get node at left is simply going to be node before left dot next, right? And then we'll iterate. We'll say for, again, we don't need this, for in range left, right minus left, right minus left, right minus left. We want to take so we'll set the temporary node like I said here. We'll need a temporary node. This temporary node will simply hold a reference to the next node of the node at left, right? Because the connection between this node, right, that I'm calling current node here, will be broken, right? So we need to keep everything else at this position, right, before we break that connection. So which is why we need this temp node here. So I don't need to, I'll call it temp, and then I'll set it to node at left dot next, right? Node at left dot next. And then after keeping a copy of every node after the node at left, then we can now change node at left to something else, right? Node at left dot next now will become temp dot next, right? Temp dot next, and then temp dot next will become node before left dot next, right? So temp dot next will simply become node before left dot next, node before left dot next, node before left dot next, and then we'll say the node before left dot next will now become the temporary node. So node before left dot next will simply become the temp, right? And then we just return. So this will happen for every right minus left times, right? So return return uh return fake node dot next. So fake node dot next. So this will return the head of the node. You know what? Let's test this out in LeetCode and see if this will work. So I'm just going to keep that here. Reverse linked list 2. I'll just copy everything else. Okay. So let's run this and see. Hopefully there is no mistakes. You can see this works just fine. You can see our nodes have been reversed at this position. So the steps are, I think this question is one of those questions you have to either read an editorial or a solution to understand. And once you understand that solution, you can then go ahead and try to explain it to see if you truly understand it. I mean, I had to look up the solution because my first approach to this solution was to extract the node in between the position where, I mean, there was a bit more steps involved in my own first method, which is not really efficient. But yeah, I guess this particular solution, I actually understood it from a couple of videos I watched and solutions I read here. So yeah, we simply need to keep a copy of our node, right, and just perform the operation. Take a temporary variable and set it to the node at left.next, and the node at left.next will become the node after the temporary node, and then set the temporary node's next value to the node before the left, right? The node before so the temporary node dot next here, right, should simply become the node at left, because the node before left dot next is simply node at left, right? But because we've already changed node at left to we've broken the bond between this. We can't still say node at left at this position here. We can't do that. It won't work. So we'll just simply take this here, and then the next step is to just reverse the, change the node before the left, or the node at left to the temp, right, which is here like this. So yeah, and at the end of the day, we return the fake node dot next, because the fake node has been, there has been a lot of mutation happening within this part here. So it will keep updating until the iteration is done. So let's submit this and see. Okay, now something is wrong. 35 out of 44 test cases. So instead of switching this position here, this has been, so what happened here? So left is 3 and right is here. So what went wrong? At least, 35 test cases have been passed, so it means we are on the right track to solving this question. So what happened? What's wrong? 34. My output is okay. So here's the input. Our left is now at this position and right is here, so which means we are simply going to switch this to here. So what's the reason why this did not get switched? So we have 4 and 3 has to go. So oh, okay. So I think right minus left is 2, right? So I mean, this case is going to be 1. So we are going to iterate. Uh, the iteration has to happen from 0 all the way to 1, but it will not include 1, which means it's going to iterate just once in this case. Interesting. If, hold on, left minus 1 fake node dot next. Okay, so I mean, fake node before left will be changed here. So I'm not sure. The problem could be from, because I mean, for this 3 to appear at this position and not here, it means we started off. It means I did something wrong here. Let's see. Output is 3. 3 shouldn't even end up here, right? It shouldn't even reach there. So so let's see. There was a solution I saw that really stood out to me. I think this is the solution. This solution was really helpful. So okay, he called his own a dummy node, which I did not. Oh, see, here's what I was doing wrong. I was still referring to fake node instead of saying node before, cause sorry, node. I knew that was where the problem was. Node before left, cause I mean, I still kept looking at the fake node, and the fake node started from 0, right? And if I'm still doing fake node dot next, I'm not really changing this. I'm simply, you know, so let's do it that way instead. Submit again. Yeah, so this solution worked, but in terms of runtime, it is slow. I'm not sure why that is, but there's still room for improvement. Since this is like a first time attempt of this particular problem, I'll just keep it this way and try to improve it next time. There's still room for improvement, honestly. So I'm just going to submit this. Let me change the node before left here. So I'm just going to push this to GitHub for you to have access to the code, and if you probably improve this solution, I'll be really glad you did that. But the point is, there's always room for improvement. So git comment m dash. So this is a linked list question. Linked lists, right? And it says reverse linked list 2, reverse linked list 2. So I'll push this commit git push origin main. All right, I think that's it for this session. Honestly, I wish I could continue today, because there are quite a number of people in the stream today, which is really exciting. But this is going to be short-lived. Anyways, it's been nice streaming today, and coming back a bit stronger than yesterday. So we shall continue tomorrow.